Well, ahoy there, mateys. We are jumping right into 1.1, which is solving simple equations. Our first Edpuzzle video. Congratulations. So for 1.1, solving simple equations, this is stuff that you have probably done before. We're just going to review it. Some vocab that you're going to need. Also, everything I'm going through is accessible through the Big Ideas website. If you click on Dynamic Classroom, you can get to everything that I'm showing you here. If you need any help with that, let me know and I'll show you during class. So the vocab that we're going to use in 1.1, some of these we're going to use more than others. So like a rule, an equation, equivalent equations, those are all very similar. An expression is basically a number sentence without an equal sign. An equation is a number sentence with an equal sign. Equations can be solved. There's a conjecture is another word you might hear. Conjecture is basically like an educated guess. Linear equation in one variable is a fancy way of saying an equation without exponents and things like that. Inverse operations is like its opposite. So like the inverse of addition is subtraction. The inverse of division is multiplication. At any time, if I'm going too fast, feel free to pause, rewind, watch it again, or just ask me during class. So this is some vocab you're going to need. If you want more precise definitions, again, you can click on, like, if you open up Dynamic Classroom, click on conjecture, it'll open up the vocab and show you what conjecture is. And, oh, there you go. So it's an unproven statement that is based on observations. Anyway, all right, back to the video. So that's the vocab we're going to need for 1.1. We're going to jump right into 1.1. So the first thing you're going to need is to be able to solve linear equations by adding or subtracting. So these are straight up equations using addition and subtraction. So let's jump into some examples of that. So the first one, solve x minus 3 equals negative 5. Go ahead and try that now. You might want to use some scratch paper. All right, now let's see how you did. Here's how I would suggest solving a problem like this. So first, let me move myself. Whee! So first, rewrite the equation on your paper, which hopefully you did. And then this is x minus 3. So you're going to want to do the inverse operation of subtraction, which is addition. So you want to use what's called the addition property of equality, which means you can add the same thing to each side of the equal sign, and that will help you solve the problem. So you add 3 here, add 3 here, and what happens is this x minus 3 plus 3 just becomes x. Like the 3 is canceled out, goes away. And then negative 5 plus 3 is negative 2. That's our answer, x equals negative 2. But then after you get the answer, you should always verify. So the way you can verify the answer is x is negative 2 is try it. So you put x minus 3 equals negative 5, replace the x with negative 2. Does negative 2 minus 3 equals negative 5? Well, yes. Yes, it does. So it works. Woo, knocked my water over. That is the correct answer. Okay. Again, if I'm going too fast, you'll have time to practice and get help in class tomorrow. You can also rewatch this video if you need. So now let's do the next example, which was 0.9 equals y plus 2.8. Try and solve this. Good luck. All right, so you rewrite the equation. The opposite of adding 2.8 is subtracting 2.8. So you want to use the, again, the addition property. And in this case, you're going to be adding a minus 2.8. So you subtract 2.8 to each side. That's going to get rid of this 2.8 over here and just leave y all by itself. So you get y all by itself. That's what we want. 0.9 minus 2.8 is negative 1.9. So that's our answer, is y equals negative 1.9, which again, you verify by plugging it in. So does negative 1.9 plus 2.8 equal 0.9? Yes, it does. It's correct. Yay, done. All right, so that is how you solve addition and subtraction problems. Okay, so now let's scroll down to our next concept, which is solving equations by multiplying and dividing. Same principle, except we're going to use multiplication and division. So try and solve this one right here. Negative n divided by 5 equals negative 3. Good luck. All right, so hopefully what you did is first rewrote it, and then realize the opposite of dividing by 5 is multiplying by 5. In this case, to get rid of this negative, you can multiply by negative 5 on each side. And then what's going to happen is this negative 5 will cancel out with this negative 5, and it leaves you with n. and that's what we want. And then negative 5 times negative 3 is 15. So there's our answer, n equals 15, yay, which we then check by plugging it in. So does 15 divided by negative 5 equal negative 3? Why, yes. Yes, it does. So that is the correct answer. Okay, let's try this one. Pi times x equals negative 2 pi. All right, so first rewrite it. And then to get rid of pi, you divide each side by pi because this means pi times x. The opposite is division. So you divide by pi. Pi cancels out here. Pi will also cancel out over here. And you're going to be left with x equals negative 2, which you can then plug in to prove it. So does negative 2 times x or times pi equal negative 2 pi? Why, yes. Yes, it does. Okay, again, if I'm going way too fast, then you should rewatch the video, slow it down a little bit, pause it when you need to. The main thing, though, is ask me for help while you're actually working through problems in class tomorrow. Okay, we'll jump to C right here, which is 1.3 times z equals 5.2. Go ahead and try and solve that one right now. Okay, so this means multiply. 1.3z means to multiply. So the opposite of that is dividing. So you want to use division property. Divide each side by 1.3. The 1.3 will cancel out, leaving you with just z. 1z equals 4, because 5.2 divided by 1.3 is 4, which again, you should plug in and check it. So does 1.3 times 4 equal 5.2? Why, yes. Yes, it does. So that is the correct answer. All right, so that is the 4 operations to solve equations. However, you will also have problems that are word problems. So you also have to solve some word problems. And the main thing to do when you're solving word problems is first understand what the problem is asking you, make a plan to solve it, and then work out your plan, solve it, and then examine your solution and see if it makes sense. So you want to do that anytime you solve word problems. And here's the first one we're going to go through. So in the 2012 Olympics, Usain Bolt won the 200-meter dash with a time of 19.32 seconds. Write and solve an equation to find his average speed to the nearest hundredth of a meter per second. Okay, what operation do you think we're going to have to do in order to find the average speed? If you said division, you are correct. And here is why. So the first thing you want to do is make sure you understand the problem. So you know the winning time, you know the distance, and you're asked to find the speed. Some of you in science may have learned what's called the distance formula. If not, I'll talk about another way to do this. So using the distance formula, which is distance equals rate times time, you could start by saying, oh, well, I know that the distance, which is d, is 200 meters, and the time, which is t, is 19.32, and I'm looking for r, which is the rate or the speed. So that's the equation you can use to solve it. To actually get the answer, you will divide. So to get r by itself, you divide each side by 19.32. So what you're really doing is 200 divided by 19.32, which gives you an average speed of about 10.35 meters per second. Extremely fast. Okay, and then you should verify to see if it makes sense. So that's the average speed we came up with. Does it make sense? Well, if it's about 10 meters per second and he's going 200 meters, it should be about 20 seconds, which is what it was. So yeah, that makes sense. It's reasonable. All right, and our last example, another word problem. On January 22nd, 1943, the temperature in Spearfish, South Dakota, fell from 54 degrees Fahrenheit at 9 in the morning to negative 4 degrees Fahrenheit at 9:27 a.m. That's crazy. How many degrees did the temperature fall? All right, let's see how you did. So first, understand the problem. Make a plan. So what I would do is figure out what information I need and come up with a number sentence for it. So their number sentence is the temperature at 9:27 had to equal the temperature at 9 minus the amount that the temperature fell. And then you can replace this with the information you know. So let's say T is the amount that it fell. This is what we're looking for. That's our variable. So we know that negative 4, which is the temperature at 9:27, equals 54 to begin with, minus the amount that it fell, minus T. And then you can solve this. So when you solve this, you'll find out that T equals 58. Okay, and go ahead and look through these steps, see if it makes sense. So 58 degrees is how much it fell. All right, so tomorrow in class, we're going to be working through problems very similar to this. I would suggest if you have questions, work through the dynamic classroom a little slower than I did in this video, or rewatch the video. If you have questions for me, make sure to write them down so you can ask me in class tomorrow. And then tomorrow we're going to be working through problems that are just like this. All right, good luck, and I will see you in class. Arr!